start. Hello everyone, thank you for coming to the first lecture of the Machine Learning Fortnight. And so today we'll be covering the introduction to recommendation systems and also have a quick overview of the competition and how it's going to go, and so that you know everything where to start. So a little bit about us. We are the Fully Connected Graph. We are the committee that organizes educational events. We did last year the Machine Learning Month. It's basically the predecessor of this competition. We did GAPSI in the previous 2 years, and yeah, we have a very wonderful team. So if you want to also join us, if you like something like this, then feel free to send us a message through Cover. So last year, the competition for the Machine Learning Month was predicting the housing prices in the Netherlands. We had at least 6 teams, as far as I remember, and I thought it went pretty cool. And this year, we are doing recommendation systems for video games. There's a lot of video games, there's a lot of data, and it's very hard sometimes to choose like which one would you like to play. So how do you even do that? Well, we'll answer this in this competition, and you'll learn how it works. So a quick overview of the whole fortnight. It will last approximately 2 weeks. We'll have the first lecture today. Then on Friday, we'll have a lecture on natural language processing for recommendation systems. Then next Monday, we'll have a lecture from a guest company, Viaviate. They specialize in vector databases, and you'll learn everything from what vector databases are to how actually program them and how to set them up. It's going to be very cool. And then on the last day of the event, the 1st of December, we'll have the finale, where the best of the participants, best of the teams will have to present their solutions, and the judges will evaluate them, and then we'll see who wins the competition. Yeah, so the contents for today: figure out what recommendation systems are, figure out what 3 types of the recommender systems are, and then look at some of the algorithms, and in the end we'll have a practical session on actually programming the stuff. So a little bit of prerequisites that I'm expecting from you is that, well, you're familiar with machine learning and linear algebra, at least on the basics level, and also have some experience with TensorFlow and Pandas. It's all right if you don't. You manage. Yeah. So for some context, every year, the world generates approximately 2.5 quintillion bytes. Oh, wait, actually, that's per day. That's crazy. So as you can see, basically, the amount of data increases exponentially every year. And those are numbers that you cannot even imagine. So on your computer, you approximately have like a terabyte of data available, and half of it is probably used by Windows or something. And then petabyte is basically 1,000 terabytes. And yeah, that's a lot of terabytes and a lot of data. So to actually figure out, to actually look through, to actually find stuff that you need in this data, in this information, you need something that can help you, and you need a tool, right? And it's very hard to just sift it through by yourself. That's why we have systems like recommender systems, which are basically used to suggest us relevant information, relevant content, so that when we need it, well, we can find it. And one important probably terminology is like the computers filter the information, so they actually sit through and like look through all the information, and that's why everything is called filtering. And yeah, as I think all of you know how important recommendation systems are. They're literally everywhere. You have them in Netflix, you have them in YouTube, you have them as search engines also somewhere places, and yeah. Any questions so far? Yes.
Completely irrelevant question to the topic right now, but are the lectures recorded and can you watch them somehow?
Yes, I am recording this one right now, and they will be available on YouTube. I will upload them as soon as possible. Yes.
All right, thank you.
So let's begin with the first type of recommendation systems called content-based recommendation systems. those are very simple and I think very easy to understand. So for example, if this user, let's call him Tom, likes these two movies, right? And we know that these movies are like romance or maybe comedy. They star like very cool actors like Tom Hanks and Meg Ryan. I have no idea what it is. And well, then we know that there is another movie, Volcano, which is exactly the same genres and exactly the same cast. So most likely, these movies are similar, and this user will probably like this movie, and that's why we recommend it to them. This is like the easiest form of recommendation systems you can come up with. They're very easy to set up, and they are pretty good to begin with, right? So a formal definition would be content-based filtering systems recommend items similar to those that the user has shown interest in based on its item features, okay? So an example could be, for example, like this. How do you choose a course in your AI program, right? So this is an example of me. So here's me, right? And I have a few topics that I like. I like artificial intelligence, I like machine learning, I hate brain, I like easy homeworks, and I don't like writing essays. And then we can see a few courses that there are available. So linear algebra, multivariable calculus. Well, it has kind of related to machine learning, has easy homeworks. Cognitive psychology, you can see you have writing essays and a lot about brains and AI and so basically from this matrix we have like an adjacency list and from it we can try to tell like which course I would like the most. Now,
Why is not the brain inside the suit? Why is the part of the brain not inside the suit? Because they're both two, all three from two.
So each dot represents that I like this or I don't. So in here it represents if I like something or I don't, and in here it represents if this topic, specific on the top, is actually present in the course.
But how would you know?
I mean,
How would you know if someone likes it or not?
We'll figure that out later.
Okay.
But for right now, let's assume we kind of know this, right?
Oh. Okay.
So from this matrix, can you tell which course from these three I would like the most? And how will you know that? Have a thought? Yeah.
Neural networks because you have the most similar dots to them.
Yes. Neural networks because it has the most interactions. Do you want to add to it?
I would think that it's actually tied with linear algebra, right? Because your dislikes match linear algebra. Like if you value likes and dislikes equally, then it's equal distance.
But linear algebra does not have the artificial intelligence inside of it.
But it also does not have brain, and neural networks does have brain.
True. I guess, that depends on how you actually model the metric. But in this case, we are considering as binary values, so it's either 0 or 1, and if it's present, then it's something that we would like to have, and we don't actually have the information if we don't like something, right? So, as the gentleman in front of us mentioned, it's the neural networks, and that is because it has the most amount of intersections, right? So one way to actually model that mathematically is basically saying that the dot product of myself, my interests, and the information that is present in the course is the highest, right? So what we can do is take the dot product, so basically sum up the scores one by one, so we see that they match up. So we have 3 points for the neural networks, we have 1 point for cognitive psychology, and 2 points for linear algebra and multivariable calculus. So from here we can tell that neural networks are kind of the most relevant for me. And if you want to actually implement that in Python, you can use it using NumPy. So you basically represent it as a one-hot encoded array. And then you multiply the student by the courses, and you get the output, which is 2 points for linear algebra, 1 point for cognitive psychology, and 3 points for neural networks. I guess fairly simple, right? This is very cool and all, but they're not the best ways to actually approach recommender systems, and they're not the easiest ways to actually do it. First of all, yeah, they're very easy to scale to a large number of users. If you know what users like and users don't, then you can upscale that to like quite a huge amount of people, right? And you don't really need any information about the people, so you don't need to know where they live, you don't need to know where they study, you just have to know what are their interests, right? However, it requires a lot of domain knowledge, and it also requires a lot of handcraftiness, because actually coming up with those features like artificial intelligence, brain, and stuff like that, it's very cumbersome, and you don't really know actually which ones will work the best. So you have to somehow work with that, right? And here comes the collaborative filtering. It's similar to what we saw before. However, now we're comparing users, I guess, to users, and movies to movies, and then we're trying to see which ones to recommend. So, for example, we know that our user Tom liked these two movies, but our user Sarah also liked these two movies. And then we know that Sarah also liked this movie, Volcano. So we might assume that because they like the similar movies, Tom will also like this movie. And yeah, so we recommend it to him. That's kind of the basic principle about collaborative filtering. And usually it is done using matrix factorization, or you could, for example, just call it an embedding for each person. So for example, you could have an embedding which represents like the age of the person. So for example, if it's -1, then the user is a child, but if it's +1, then they're like an adult. And then they will like more adult movies, and somewhere in between you have like the teenagers who just like Harry Potter and yeah. So this is like one-dimensional representation of all the users, right? And you can learn that from this adjacency matrix. So just matrix, I guess, review matrix. So yeah, this grandma likes these two movies, which are for the older generation, and yeah, they like these movies. And basically, you can try to model this by just, for example, multiplying the top vector with this vector, and then you get this matrix that is similar to this, represents this matrix, and then you can try to use that to get the reviews. However, one dimension is not really enough, so we can upscale that to 2 dimensions, for example. Now we have like 2 dimensions in this case, which are like the age, and for example, which type of movies they like. So for example, it's like more artsy movies, and this one guy likes more blockbuster movies. And so our users now are represented in a more bigger space, more higher dimensional space, which can represent more information about the users. In this case, similarly, we can try to model this using these vectors, and then if we multiply them, we can get the ratings that there are. And the cool thing about this is that now when you have the vector for the user and the vector for a movie, you can try to multiply them and see what will be the result for the movie and user pair that you have never seen yet. So for example, in this case, it would be like -1, so probably they will not like it. Yeah. This is kind of the idea behind collaborative filtering. So for the majority of the cases, it's done using matrix factorization. In simple terms, we have a matrix for each user, and for each movie. And yeah, then we can multiply these vectors and get the values for what user will like and which movie it is, right? And okay, so when we actually do this, well, how do we actually do this? We can do it using a minimization task, right? So if we have this matrix A, which is the reviews, we can model it just by multiplying the 2 previous matrices and then subtracting it and minimizing the loss between them, so minimizing the difference between them. And this task is very similar, and you've probably seen something like that in your linear algebra course, or I hope at least. It's something called SVD. Has anyone heard about it? Okay, one person heard about it. Okay. So SVD is actually the exact solution to this equation. However, it disregards the fact that you actually have missing values in your matrices. So if the problem is that there are some values that you don't know about, and SVD assumes that you have the full matrix complete. And also, it's very hard to do SVD because even if you fill the matrices with zeros, for example, and you try to do it, the matrix is going to be super huge. Like if you have 1 billion users and you have 1 trillion videos on YouTube, then the matrix is going to be like huge, and the values, like your computer will just die from that basically. So that's why there are different algorithms which are able to solve this, and we'll look them a little later. Another thing to mention, I think, is weighted matrix factorization. So it is basically exactly the same equation. However, now we also have a weight for the values that have no observations. And that is basically like a regularization factor, so that our model does not overfit. Because if it predicts that, oh yeah, everyone likes everything, then, well, it's not going to work, right? And that's why regularization could be very useful for this task. Yeah, so now let's look at the optimization part of it. Hi. Yeah. So one way to actually solve and find these two matrices, so the user matrix and the item matrix, is just using stochastic gradient descent, because, well, we know this task is easily modeled by just linear equations, by just multiplying vectors with matrices. We can solve it using stochastic gradient descent, and it's a generic algorithm. So you can use it basically to minimize anything, including this task. And in this case, you actually solve for the user matrices and item matrices at the same time. Another way to actually solve this is alternating least squares. So this method is specifically made for matrix factorization. It is very similar to SVD, but it tries first to let's say that the movies are fixed, then we optimize for the users. And then we fix the users and optimize for the movies. And then it can be mathematically proven that at some point this actually converges. And that's very nice because in the end we can get the same answer as if we just did the stochastic gradient descent. And these two methods have their own pros and cons. So stochastic gradient descent is very flexible. You can use it for any loss function that you want. It doesn't specifically have to be the squared difference that we chose before, root mean squared error, yes. So you can choose something else, for example, like binary cross entropy loss. Then you can use stochastic gradient descent. It can be parallelized. However, it is very slow, and the convergence for stochastic gradient descent takes some time. On the other hand, alternating least squared is specifically made so that it can factorize matrices. That's why it's going to work much faster and much better on this task. So if you actually want to learn more, read more about this, I took the inspiration for these slides from the Google Machine Learning course on recommendation systems. So you can also go there and read more about it. They have code and implementations. And they also go through how to actually use deep neural networks to predict what users will like and not. Any questions so far? Okay, then let's go on to the practical session, and maybe let's have a mini break. Let's have a break for 5 minutes maybe, grab some water. We'll upload the Google Colab notebook in the internet, and then you'll be able to work with your stuff. Okay? Bro, this.
I missed the last perspective.
practical session, the notebook and the data and everything is located on the website. So if you go to the mlfortnight.svcover.nl, you'll be forwarded to this page. And if you scroll down, there will be the event structure, and then there will be like lecture 1 notebook link. And if you go to it, you'll open the assignment, and there will be a bunch of to-dos that you have to fill in. And you also have like model answers. And using them, you can make a recommendation system for movies. Yeah. This will cover. Hi. Yeah, so go to this link, mlfortnight.svcover.nl. There you will be forwarded to this page. There you will be just scrolling down, and then there will be lecture 1 notebook. When you open it, you'll open a Google Colab page, like this. And in there, you will be able to solve the assignment. So you'll have to build a movie recommendation system. The data set is from the
Movie Lens.
Yeah, it's a Movie Lens data set. You will be able to download it and then work with it. And there will be to-dos. For example, not here. For example, here. So you have like a to-do, you have to do something, it explains what you have to do. And if you cannot figure it out, you just ask for the answer. It will be like openable here. If you want to run your code, you have like a play button right next to the code. So you press on it, you select run anyway. And you just run it one by one. So it's an interactive Python notebook. If you haven't seen it before. And read through it. It has useful stuff, explains how everything works, and how to implement stuff also. All right. Good luck.
I might miss this one, but do we have to copy the project and then edit ourselves? Or can we edit right away? Replace the name?
If you want, you can copy it. Then you will have your own copy. You don't have to copy. It works like that also. But if you don't copy, then your savings, like what you wrote later, will be lost. If that's all right with you.
So it's better to copy.
You also have the answers in there, so it's fine. Like,
For the registration, because we didn't put this in.
Okay.
So can we group?
Did you all register for the competition? Did you get the link on the email? I'll send you the link. If you registered properly through the registration form, you should have gotten a link to the competition last night. And it will forward you to Kaggle. Where am I? How do I do this? Okay, so for those who registered for the competition, this is how the competition page looks. So, you can watch the data here. You can also download it down there. You have the training and test set. The leaderboard is here. So if you submit something, submit predictions. There is also an instruction how to submit predictions. If you're looking for a team, you can mention yourself here like, oh, I want to have a team, and you get a arm right next to your submissions. And you can also write about yourself. if you want to actually make a team, you just send an invitation. So for anyone who is actually participating in the contest, you just write their name. So it could be Ali, for example, and then the user will be added to your team, or they will get a message that you want to add them. Yeah. If you have any questions about the notebook, so if you are having some struggles or want to ask about something theoretical, then yeah, feel free to ask me or Jeremiah. Yeah.